200. 27, degree 3 with -2, 1, and 4 as zeros. Okay, so we'll do x plus 2, x minus 1, x minus 4, and we'll do a leading coefficient of... They had you FOIL it out. I don't care if you FOIL it out or not. Even though it's vertically stretched or shrunk, it's still going to cross at the same place. Not if you put it before it like that. That's like having a GCF that you take out in the beginning. So 29 has degree 3, 2, 1/2, and 3/2 as zeros. You could do, so obviously this one's x minus 2. This one is, you could do 2x, or you could just do x minus 1/2 if you wanted to.
That's really number. Wait, what's that 2? What is that left?
It said in the beginning it has to have a leading coefficient of 2. It was really easy. Yeah. Anything else? 23? Huh? Number 3. Did y'all have that last night? Number 3. F of x equals x to the third plus 4x squared plus 7x minus 9, and I'm dividing by x plus 3. And so it says divide and write a summary statement in polynomial form and fraction form. So I'm going to do -3 on the outside because this is a synthetic division one. This one can be done synthetically, so I would definitely do it. It didn't specify which way you had to do it, so I would do it synthetically. 1, 4, 7 and -9. -3, 4, -4, -13. So I would say that it's x squared plus x plus 4 minus 13 over x plus 3. Lily's back with your pictures. We've all been waiting on. I'll try to make this short and sweet since we've done it. I got to show you PRZs, and I've got to show you upper and lower bounds, and outside of that, we'll be done. Tell me what a PRZ is. Possible, rational, zero. These are possibilities. They may or may not be a zero, and we test them the way we know to test them to see if they are zeros. How do we test zeros to see if they're actually zeros? We can plug them in and see if we get 0, or we can divide by x minus that number. We can do synthetic division and see if we get no remainder. All right, so how do we find PRZs? Do you remember? Okay. Factors of which comes first? It does. It's factors of the constant divided by factors of the leading coefficient. And this is where we do the plus or minuses in front. We list them all out. If I need to go in more detail with any of this, let me know, because I'm assuming you just need a little bit of a refresher from last year. But if I need to go back. Okay, so let me show you what I mean. If I had this, and I asked you to list the PRZs, Well, I need to take a look at the leading coefficient and the constant, right? What are all the factors of the constant, right? And what are all the factors of the leading coefficient? So I need to make every possible combination I can of fractions, taking these numbers and, whoop. Brett, please don't do that again. It's so aggravating. Move the screen like that. It's okay. Every possible combination I can of these numbers divided by these numbers. So my PRZs here would be, and this is where I'm going to do plus or minus, because two negatives here would make a positive. 1, I'm going to divide them all by 1 first. So they would just be themselves, right? 1 and 2. Now I'm going to take them all and divide them by 3. 1/3 and 2/3. So these are my possibilities. Does that make sense? You remember doing that? So how can I decide which ones of these are actual? Because if it's something like this and I'm asked to find the zeros, well, that's not factorable. And if I don't have a calculator to graph with me, then I may need to figure out a different way that I can find these zeros. So I list the PRZs. So I guess let me give you some steps here to find zeros. I'm going to list the PRZs first. Your notes will probably look better than mine, I'm sorry. Test your PRZs until you find one that works. Since I'm being asked to find all the zeros here, instead of plugging in, I'm going to use my synthetic division. And I'll show you why this matters in a minute. Bless you. So start trying them. See what you get. See what you can come up with. Which one works? There's a huge. So I take all of these and I divided it first by 1. So 1 divided by 1 is this one. 2 divided by 1 is this one. Then I take all of these and I divide them by 3. So 1 divided by 3 is this one, and 2 divided by 3 is that last one. Anyone find one that works yet? 1. Oh, y'all got lucky. If I try 1, 3, 4, -5, -2. So you can, but here's why I don't want to do that. Because if I'm trying to find all the zeros, that would tell me one to start with. But if I start with that one, my next step is I need to write this as a multiplication problem so that I can factor it all the way. And if you didn't divide it, you wouldn't know what that other factor was. So in other words, I take that one that worked, which was 1, right? So that's x minus 1. Ugh. And I multiply it by what? Uh-huh. That's exactly right. Y'all remember doing this, right? What do I do now? Factor. Charlie, did you see if I just plugged it in, I wouldn't have gotten that 3x squared. What multiplies to 6x squared but adds to 7x? 6 and 1. I can't use the shortcut here. Why? There's a leading coefficient. That's exactly right. Y'all doing this? Y'all are just quiet. I can take a 3x out of the first two and a 1 out of the second two, which leaves me with x plus 2. Am I done? No, because I was asked to find what? The zeros. So to find the zeros now, it's easy. What are they? Set it equal to 0. That's exactly right. 1, -2. How about this one? Subtract 1 and divide by 3. That's exactly right. It's not. You mean from last year? Okay, so this time, you literally just start with the equation and you have to test the points and find it works. Everybody okay there? Because I'm fixing to throw something new in here. Good? Very last thing for this section. Ooh. Upper and lower bounds of zeros. What in the world? Brett, please. Just try that. If you synthetically divide and get all positive numbers, then it's an upper bound. And I'll show you exactly what I mean. I just want to give you the rules first. If you synthetically divide and get, you would think I'm going to say negative, right? But it's not. Alternating signs. What does that mean? Exactly. Then it's a lower bound. Then it's not a bound. So this just tells you that my zeros are never bigger than this value or smaller than that value, which is helpful whenever you don't know what they are. As long as it's alternating. It could be positive, negative, positive, or it could be negative, positive, negative, positive. That's still alternating. Still alternating. So for example, y'all got all that? Y'all look like y'all are tired. I promise I'm gonna give you time to do your work. Yep. You can't wait to do this work, can you? Say again? That's still alternating. I understand. That's why I answered it. All right, let me show you an example. One example, I'll be good. Oh my goodness. I know. Why do you care what my ringer is, Brett? It's so loud and terrible in third block, we don't even hear it. I'll mute it. I worry one of my children need me. Well, Kenzie's here, but I worry and then I don't hear it ringing. Brett, do not be a jerk, okay? I still don't understand why it says private number. All right. Four. This is the way these are going to be set up most of the time, is show that this is an upper bound, show that this is a lower bound, or show that these are the bounds for the function. So what that means is I'm just going to synthetically divide by -2, and then I'm going to synthetically divide by 5. What you mean? Well, so yes. So what it's saying is that your zeros have to fall between -2 and 5. So we're treating this like a zero is what we're doing. We're saying divide by x plus 2 and see what happens. So I'm going to do -2 on the outside, and I get, here that's 2, let's see, 4, 3, 2. Watch your placeholders. -7, -8, 14, and 8. And I'm just going to run through this quickly. 2, -4, -11, 22. What is that? -10 would be 12 plus 2, 14. Is that right? Bless you. -28. Is this right? Oh, that would be my lower bound. That's right. 28, which would be 36. Notice the signs. Positive, negative, positive, negative, positive. They are alternating, right? So I can say, therefore, have y'all seen me use those little signs before? Okay, therefore, x equals -2 is a lower bound. And what that means is, no matter what my zeros are, where it crosses the x-axis, It's not going to cross anywhere smaller than -2. It won't go past there. It's a lower bound. Does that make sense? Never being smaller. So now test 5. If 5 is an upper bound, what should happen when I divide by it? They should all be positive. So divide, you try that one and see what happens. Get all positive numbers? The answer itself is not that important as far as what I get when I divide. What's important is that they're all positive, and that tells me that x equals 5 is an upper bound. So that tells me that whatever my zeros are, they all fall between the values of -2 and 5. So that's a pretty small window, because if I listed out all my PRZs, I could automatically eliminate any that were smaller than -2 or bigger than 5. Does that make sense? All negative wouldn't be a bound. This not a bound. All right, I think that's it. Because you're in your homework, it's going to give you a value and it's going to say show that this is an upper bound or show that this is a lower bound. All right, so what I'll have you do, and you have a long time to do it in, so you can do it in class today. Yay! Yes. Um. Okay, this looks like a lot, but these are not a lot because these are just listing the rational zeros or testing one end of a bound. Your PRZ problems, we're not going to do that many of them. Let's do 49, 51, 49 through 55 odd. One more, and that's it, I promise.